Track 4, diagnosing well issues. So here the patient is the gas well and the doctor is an RTA engineer. This is going to show what it looks like if you're analyzing your gas wells back home and you're trying to history match flowing pressure given your producing gas rate. This is the best history match achievable with the conditions or constraints that were provided for initial reservoir pressure and for calculated sand phase pressure. It doesn't get a better match than this, and it's not a good match. So what is the data telling us that we need to know? In this case, we've got an error percentage of over 50% as our best history match available. And look at how good that data looks. That's textbook. It couldn't look any nicer. Dry gas well data often looks like this. And you can see in the buildup response that I've highlighted here, you know, the model is far outshooting the actual observed buildup. So what's going on? Well, a lot of this can be detective work where you use RTA as forensic science, and this relates to the theory of percentage drawdown. Our belief is that a lot of our wells are higher drawdown than they actually are. When we only have rate-time relationships, we have no way of diagnosing the health of a well. To whether there's pressure restrictions downhole, whether there's operational issues, particularly with pumping wells, if the pumps aren't working efficiently, how would you ever know? There are methods to do that, but this is a real practical, simple way of doing it. In this case, we believe that we're high drawdown, meaning small changes in flowing pressure shouldn't have any impact on the effect in a significant way on the producing gas rate. But in fact, in this example, we're seeing that. If we lower initial reservoir pressure or we increase bottom hole flowing pressure, we can get a history match that looks like this. We can come up with a 1% error, changing very little, which tells us that this well is not as high drawdown as we thought it was. We had discussions over initial reservoir pressure and whether that could be validated. In this case, it was a lot of evidence to support the PI. Therefore, there was something going on in the bottom of the well that was causing a pressure restriction. And in this case, this well, I believe, had jewelry left behind. They could be unmilled out ball seats. It could be a number of issues. That certainly might not be the issue, but a variety of issues could cause this. Now, what if, well, I'll get there. I first want to take a look at the percentage drawdown plotted through time is what it looks like. We thought we were in purple at 90%. We're probably closer to 60% drawdown. This well has performance uplift potential. This is just an example of different images in a wellbore that could be causing delta Ps, that could be causing this observed back pressure effect and this lower drawdown percentage that we're producing this well at. It can get really ugly down there, and of course we rarely have these images, so we don't always know. But if we see this in the RTA, if you diagnose a number of candidates where this is a problem, that would be your candidate list that you might want to go back and maybe run a camera, diagnose the issue, because this is low-hanging fruit if we can do a clean out to solve a problem or do a very cost-effective workover. The potential of upside in terms of accelerating reserve recovery or even changing EURs can be done in RTA. So we can just remove that pressure restriction to see what the performance upside would be. And here we can see in the red series where the well is headed, and in the purple or magenta series that what it would look like to remove that pressure restriction tomorrow and see what we could realize in terms of production on this well.